Hello everyone, welcome you all to Water and Wastewater Tech Talk. It's a Technobiz virtual event, and Technobiz organizes a number of virtual events for the benefit of professionals working in the industry. You can always check the various virtual events at the virtualevents.technobiz.org. And today's episode of the Water and Wastewater Tech Talk, we have invited guest Mr. Lalit Vashishta. He's a CEO and founder of the Diva Envitech Private Limited based in India. We'll be talking on the subtopic of the DISORB system, enhancing produce water treatment, efficiency, and sustainability in the oil and gas sector. Before I let him give a talk, let me quickly brief you about Lalit Vashishta and his experience. Lalit is an accomplished chemical process engineer and entrepreneur with a wealth of experience in process engineering, filtration technologies, and industrial wastewater treatment. He is the founder and CEO of the Diva Envitech Private Limited, a leading process engineering company with over 30 years of expertise in this industry. He is a chemical engineering graduate from the National Institute of Technology, Rourkela. He is also co-founder of the three other startups, Ecoban Private Limited, Molipore Membranes Private Limited, and Diva NatuArg Private Limited that focus on the composting, industrial membranes, and the sustainable agriculture. Aside from his entrepreneurial ventures, he holds various leadership positions. He is the vice chairman of the Indian Institute of Chemical Engineers Mumbai chapter for the 2021 to 23. He's also director of the Indian Environment Association and technical cadre for the, and also he's technical cadre for the Rotary Foundation. He's also director of the Institute of Separation Science and Technology. So he has associated with various professional organizations as well. With over 35 years experience in separation and filtration technologies, he has extensive knowledge of latest technologies in treating recalcitrant COD and toxic wastewater. His expertise include proprietary CHD ox catalytic hydro-oxidation technology, PHD ox technology for spent caustic from refinery based on catalytic wet air oxidation in continuous mode, resonance and plasma for process intensification, and DISORB for oily produce water treatment in PWT is a game changer. These competencies provide Diva Envitech with a competitive advantage in the industry. As a leader of Diva Envitech team, Lalit creates customized solutions for all process engineering needs in API, pharma, chemical, petrochemical, refining, oil and gas, dyes, pigment, sugar, distillery, and wastewater sector. His process troubleshooting approach helps organizations improve process efficiencies, work towards sustainability, and enhance their bottom lines. It's a pleasure to have Mr. Lalit Vashishta to give a talk on today's episode of the Water and Wastewater Tech Talk on DISORB system, enhancing produce water treatment efficiency and sustainability in the oil and gas sector. So Lalit, welcome to the program, and please make a presentation.
Thank you very much, Feram, for that introduction. And very good afternoon, good morning, good evening, wherever you are from, listening from. It's a pleasure to come and share my thoughts, my ideas, and some information on wastewater technologies which we have developed over the years. So today we will be specifically talking about DISORB. So before I jump into the topic, let me just give a little brief on what our company is all about. We are based out of Mumbai, and we have offices in different parts of the world. We have offices in the US, London, and then we have branches in different parts of the world, in South Africa. We have done projects in different parts of the world, more than 600 plus projects. So I think 4 companies he mentioned about, Colossal Consulting, I think he missed, which is a Dubai-based company. We have mainly for the analytical and for testing for the refining and oil industry. So as a company, we are totally focused on sustainability and slowly we are taking most of the companies, we are training them to think on a circular economy rather than thinking linear. The world has been thinking linear, and that is where we have landed today. The problem of the world is that we have not really thought of the cradle to grave concept and how to use the final product. So that is what has been missing, and we are now trying to, you know, with my lectures, we have some lectures on sustainability, we talk about process intensification with different companies. The journey has started from 95. We have come to 21, where our focus is now concentrated on wastewater. But beyond that, we are also in hot gas filtration, catalyst filtration, hot gas liquid sparging systems. So it's a very wide range of products which we offer. And in 35 years in this business, we are capable of designing very critical systems. Our focus areas, if you can see from this chart, from this illustration, that we are basically focusing on reducing waste, reducing costs, saving water, recycle, reuse. These are the buzzwords which will lead us to a sustainable living down the line. Sustainable manufacturing has to focus on these areas, starting from energy efficiency to process intensification. So the 5 verticals we work in: filtration and separation, reaction engineering, thermal operation, mass transfer operation, and wastewater treatment. So we will not delve too much into the areas. You will have my contacts from Pelham after the presentation, and then you can always, get further information if you are interested. Some critical products which we have developed over the years, these are our own products, which are DISORB, which we will be discussing in detail today. Then we have the ProMem, which is the membrane-based systems, PHTOX, spent caustic treatment for refinery, oil and gas sector, supercap aeration systems, molypore membrane, Rosonics for using cavitation as a process, and Quantifilt for the filtration and catalyst. So let us just give you a brief on Viva Consultants, Colossal Consultants in UAE. So you can see a wide range of offerings from there. So if it resonates with you, you can always connect. So without spending much more time, let me just delve straight into the topic while we are here. And we are going to be discussing the DISORB technology. It's the oil separation technology for oily wastewater treatment. Now, you all must be aware of different type of wastewater treatment where oils are concerned. So you have the straight interceptors, then we have the DAS systems, then we have the nutshell filters, we have the skimmers. There are so many technologies available, and we also know the challenges which they come. So we have understood, and we are trying to address these challenges using our DISORB. So what is DISORB? DISORB is an innovative, revolutionary technology in the oil and gas sector. We don't use any coatings, no polymers are used to create DISORB particles. It is basically an inherently oleophobic material. So it is made by calcining, and then it is sized. We are getting some advantages. We get very high recovery of oil and water for recycle and reuse. We get high removal of oil and TSS. Now, oil and TSS together can be a nightmare in the produced water or in a refinery, where the sludgy waters come. It carries a lot of total suspended solids. And when oil and suspended solids get together, you get very greasy, lumpy masses. And especially in the produced water plant, I don't know how many are from the produced water sector right now. The nutshell filters down the line, they get very badly choked, and sometimes you open and use crowbars to remove the media out. So we will be talking about the various advantages our media gives compared to the typical nutshell filter and the other the other technologies which are preceding a nutshell filter. So it's a disruptive technology. It efficiently recovers water. It's oleophobic, as well as the certain layers are hydrophilic in nature. So it has got anti-clumping coalescence, and it also controls hygroscopicity. So you can imagine we are trying to bring in so many characters in the media, and it comes with its inherent advantages. It can be used in various parts in the oil industry. We have upstream water filtration. You have the frac water, which carries oil with it. You have the produced water, downstream waters. You have the slop oil waters in then processed water tailing ponds in refineries, then midstream oil transportation and storage, tank cleaning, oil recycling, and then soil remediation and oil removal. Now, I'm sure some of these applications you will be able to resonate if you belong to that industry. But having said that, I would say that this particular product which we have made is also it also has immense applications in other industries. For example, the metal industry, where you have this cutting oil, and on the rolling mills you have these oils and particles of metals and sludgy mass coming. It works beautifully over there. In edible oil factories, where wash waters come to the effluent treatment, you all know that oil coming to the effluent treatment can cause havoc to the biology of the system. So whenever you have a biological treatment plant in any factory, you have to take care that the oil does not enter there. And the conventional methods which we are presently using, like a dissolved air flotation or dissolved gas flotation or induced gas flotation, or depurators or corrugated plate interceptors, so many, there can be challenges in managing them, and those challenges can actually have certain surges of oil entering into the biological plants, which create a lot of problems. We all know the principles behind coalescence. You have a particle, or rather, when I say particle, it's a droplet which goes at a particular velocity, and when it impinges against a fiber or a surface, in case of a plate interceptor, it's a plate which it impinges on. In coalescers, it goes and impinges on fibers, and in our media, it goes and impinges on the media. So but the principle of coalescence remains same. So you have the submicron flows around the target, droplet strikes, it loses its velocity. Several captured droplets coalesce, forming a larger one, and then they trickle down and fall. So this is the principle behind coalescence. And if you look at the chart, you can use different technologies to treat different type of oils in water, or rather emulsions, colloidal emulsions, and that depends what is the size of the droplet which you are intercepting. So moment you are getting to, let's say, less than 1 micron droplet, the microfibers, the hydrophobic fine fibers and membranes come into picture. Then you have the ultrafiltration, where there are much larger particles to be removed, droplets to be removed. Ultrafiltration does a wonderful job. Now we have introduced the complete ceramic range of oil removal systems. So based on the application, we decide whether we want to use a membrane, an ultrafiltration, or we are going to use the DISORB media. But for produced water, predominantly it is going to be DISORB because of the various reasons which we will discuss today. So same droplet coming, losing its velocity, it goes on the filament or the particle where it hits. It's a quick test to see how the emulsions are. If you take a water sample and you keep it aside, if the settling takes place in less than a minute, that means the droplet sizes are settling, or the flotation of the oil takes place in less than 1 minute separation. 2 layers are formed. Then it is a oil droplet more than 500 microns. If it is taking level, it is about 10 or less than 10 minutes. It is between 100 and 500. So it's a weak emulsion. If it is taking hours, then it is a moderate emulsion, and normally the particle sizes are in the 40 to 100 microns. And if it's taking days, it is very strong emulsion. It's a very stable emulsion, and droplet sizes can be 1 to 40 microns. And if it is a very strong one, it never separates out. So it's blended with each other, made for each other, loving each other forever. That kind of a bond they form. And these are called the colloidal suspension. And there the particles or the droplets are less than micron or sub-micron. And these are very tough to handle. So different type of technologies in the industry which are used. I'm just giving a brief so that you can, understand. I'm sure people must be using some of these technologies, and you'll be able to relate to what we are offering. So I will just move forward on this. There's a lot on coalescence and different type of mediums, different type of coalescing media which are available in the market. So how does a DISORB work? Now let us come straight to DISORB. So heavier the oil, higher the oil and TSS removal, the DISORB works the best. Now we're looking at 1 to 300 ppm oil and TSS, greater than 99% of removal of both oil and TSS takes place. So the brown thing which you see in the graphic next to the text is the media. So it is a very irregular shape. It's not a fully spherical shape media. And the droplets of oil, you can see they are sitting so beautifully between the crevices, and they are not sticking to the media. Unlike the nutshell filter, where oil goes and spreads over the nutshell. Here it is sitting in a globular form, and the reason behind it is that the media is oleophobic. That means it hates oil. Oleophobic is oleo means oil, phobic means has a fear to oil. So second, if you look at, we put in about 300 to 700 ppm oil and TSS, we get almost 99% removal. So far you see 1 to 300 also we got 99, 300 to 700 also 99. You will see in produced water plants or in even refineries, sometimes you get the loadings can go very high. Suddenly a stock of 3000 ppm comes. Intermittent load, even that is handled by this media, and the outlet does not change. So this is a graphic showing the magnification of the media. So you see the structure when it is at a 19 kx, the 5 micron range, you can see how it looks. And this is a 500 micron. You can see the second one. And third one, you see the structure is layered and very porous. The oleophobicity comes from its natural clay-like material, which is calcined at 1200 degrees centigrade and then granulated. DISORB granule media are made of opal cristobalite rock with high porosity and oleophobic property. These properties create a water shield that prevents fouling or addition of oils or pollutants, and broken particles retain performance characteristics. So it does not matter if it chips, it breaks, and even if it breaks, the fresh surface which comes out is having the same property. It's not that we have surface coated it. It is inherently the whole media itself is having the same property. So by abrasion, if the particles break somehow, although the breakage is very, very low, I'll come in one of the slides to show you, compared to a nutshell, how much is the breakage in this. DISORB media is a proprietary pelletizing biogenic sedimentary algae with the highest hygroscopicity for pollutant entrapment. So here is a comparison between a nutshell media and a DISORB media. What is a nutshell media doing? You have nutshells, you know what a nutshell media is. If you don't know, let me tell you. So this is basically the walnut, the shell of that has certain properties. So some companies in the past have broken it, sized it. You get different type of sizes, and they fill it up in a bed like a sand filter or a mixed bed media filter. They put nutshells into it, and the nutshell media's working principle is adsorption. Whereas our DISORB media has a principle of coalescence. We discussed coalescence in a few slides before. So you can see in adsorption what happens is the oil goes and spreads all over the media. Whereas in coalescence, it does not even stick to the surface of the media, but because of losing its velocity while it's traveling, the coalescing effect starts. Lower retention of oil and PSF in natural media, whereas in our DISORB media, we have 10 times higher retention in oil. So you can imagine the magnitude of difference. We are talking about 10x difference. Natural needs very vigorous agitation scrubbing with backwash. Like I told you in the beginning, the principle is absorption, that means oil gets stuck on the surface. So to now remove it, you actually need to scrub it like a brush you have to do. But since you can't do brush, so what we do is we put air, we put backwash at a high velocity, and we create agitation in the whole bed so that we can, clean up the whole media. Here, since nothing sticks to it, even if the part, and this actually acts like a sand filter, so it also captures TSS, it captures oil, and the beauty of its oleophobicity does not allow this oil and the suspended solids to stick to it. So the moment you give a very small backwash, everything dissipates and comes out within seconds. The washing time of a backwash in a DISORB media system is approximately 30 to 35 seconds. First 35 seconds when you do the washing, all the oil comes out. So you can actually recover the oil which has gone waste earlier into the water plant, which gets stuck, becomes a sludge, and you have to throw it somewhere. Here you can actually start recovering the oil on a regular basis, and then you clean the filter. It cleans in about 1.5 minutes, 2 minutes, and the next cycle starts. Backwash volume, huge backwash volume, 1.5 times percent of the treated water volume is required in nutshell, whereas 0.2 to 0.6 backwash volume is required in a DISORB media. Oil inlet limitation is there in a nutshell, that is less than 100 ppm in oil and water, where we say that beyond 100 ppm, a lot of oil will start bypassing the filter, the nutshell media. Here, oil inlet can be as high as 300, and like I showed in the previous slide, it could go as high as 3000 ppm. And there is an application which I will cover in one of the slides later on, where we have handled a shock of 25,000 ppm coming into the field, and the outlet was only 5 ppm. So you can see the way this media behaves. Attrition loss. Now, nutshell has an attrition loss of 10% per year, and the reason is because we are getting very frequent backwashes and we are giving very vigorous backwashes. So scrubbing, hitting with each other, they start breaking. Nutshell media, when you have eaten walnut, you put it in your teeth, it just cracks. So here, attrition loss is more than 10% per year, whereas attrition losses in a DISORB media, because it is quite gentle, is only less than 1% per year. So because of that, only you can see the life of the bed is extended. So 2 years versus 5 years expected operating life. So that is the standing out advantages which a nutshell and DISORB have against each other. So DISORB stands out like a brilliant chap now. Now coming to a typical produced water treatment scheme, we have a skim tank normally typical. I'm not saying that is everywhere. It could be a skim tank. There could be an intermediate stage before the IGF, which is the induced gas rotation. Before that, there could be a CPI or TPI, whatever you call it, paid sectors. Then we could go to an IGF, where oil could come down to 30 to 40 ppm. Then it is taken to a nutshell filter, where it comes down to less than 5 ppm. So you see, nutshell can barely take loads more than 40, 50 ppm on a continuous basis. So we can actually come in, replace the complete IGF and NSF from the plant. It can be thrown out, and we can actually use the vessels of the NSF, remove the media, and we can fill it up with the DISORB media, and straight from the skim tank, you go to less than 3 ppm in one shot. So you can see the number of operations which are stopping now, the way the system is going to work, the ease of operation. Now I will be showing you how the coalescence takes place. It's a very small video which will show you how the coalescence takes place. This is an active thing taken on 2020. The speed of this video is 32x, so it's a much accelerated video. So you can see water coming in with some ppm of oil and how it comes, impinges on the media. Slowly the small droplets get together and they start building. So this time was 14:55. Now this is about 15 minutes later. You see the oil has now coalesced into lumps. They are becoming bigger and bigger. The time lapse will go further and you will see how the bed will start filling up with oil. That video will be the next one which I'll show you, where you will see how the bed starts filling up from a very nice golden brown color. The whole bed becomes dark because of the oil it is capturing over a period of time. What you should really notice here is that the hydrophobicity of the media is so beautifully represented in this video. Now you see this is let me take a laser out. Yeah. So this you see is the bed. It's a lab bed, and you see the oil is percolating down slowly. What you see on a big screen here, the whole oil will fill up the bed, and moment you see the passage coming, that is the time to backwash the bed. It creates voids so that water can continue to pass, but at the same time the oil starts filling up the bed. You see the oil trickling down here. It is amazing how oil behaves with this media. Okay, so let us move on to the next slide, next image. A pilot just demonstrate how the media is working. How the backwash. It is being fed into a specific bed which gets created just to demonstrate how the media works. And what will be coming out, the first thing will be the so from a dark, blackish colored healthy water, we are coming slightly larger oily water. Here we have taken a stick. If you take them to the house, then I here the that is how the passes and what you get here of clean water comes out. No ICF, no CPI, no nothing, nothing. Just passing through this column, the water has become absolutely clean. It's not magic, it is true. And I know some people will say it is too good to be true, but yes, it does happen like that. Fine. So
Okay,
this is this is the application where we are talking of a very small pilot again. It's a 15 meter cube per hour. The service flux rate is meters per hour is 18 to 21. Now, when I talk about service flux rate, that is basically the velocity which you will use, and that is dependent on quite a few factors. One factor is the API, the oil viscosity, what kind of oil it is, then how much is the loading of solids, what is the total load, etc., and what is the top size of the oil. So the velocities have to be varied based on the application. I'll explain a little bit on different velocities. This is the backwash.
กินข้าวอีกแล้ว
I can hear a voice, baby talking. Anyway, so we have an inlet ranging from 4 to 906, and outlet of the oil at the bottom you see is in the range of 0.1 to 5 ppm. Coming to the graphical representations, this was started in around 8th of July, and up to November the readings have been taken. And you will see backwashes were initially based on breakthrough beyond 5 ppm. So when the oil became more than 5 ppm in the product, then we used to do the backwash. Otherwise, we can also set it up on a differential pressure basis, finally operating on a time-based backwash. So, you know, you go to a site and then you see the loads. Statistically, then you come to a thing that, you know, maybe after 24 hours, you have to do one backwash, depending on the oil loads, etc. The red ones are the backwash cycle, and then you see the amount of water which has passed through. The peak loads of 50 ppm. The next one you see is about 100 to 200 meter cube per hour plant, which is again produced water. The loads are backwash flow rate is 450, and the service flux rate was around 18 to 21.5. You had a peak load of oil in the inlet up to 200 sometimes, but normally it was 8 to 10, and outlet was always coming to 0.1 to 5 ppm. Now you look at this graph here, you have the inlet parameters, and this peak you see, which is around 200 plus. So that is the peak, and the outlet is the blue line at the bottom. You see that it is always less than 5 ppm. So it did not matter what the incoming load was, 75, sometimes it was very less, sometimes it was peaking 200. The outlet quality did not vary. That is the beauty of this system. So produced water from skim tank is being treated directly through DISORB media. IGS is being bypassed now in this site. Stable output for the past 90 days. Backwashes were initially timed based on breakthrough, and finally it is based on TP. So this is the present status of the site. Now this is another site with a bitumen production thermal plant. Here we have done 558 meter cube per hour. So from DISORB it goes straight to a granulated activated carbon, then to an RO, then to an ion exchange to a boiler. So the water is becoming a boiler feed water in this case. So the DISORB was being used to protect the ultrafiltration membranes. 130 meter cube DISORB was used in 2 filters, and we used a filtration speed of 40. Inlet parameters were 40 to 60, and outlet was 0.1 to 2 milligrams per liter. It's been operating since February 2019. 3 identical projects targeted in completion of 2022. So now, because of some delays, this has gone a bit further. Total oil increase, again, you can see the backwash media, the input quality you can see in the image, and how it became very, very clean water. These are some of the images of different type of waters. Now, when I say ASP, that is the surfactant and polymer based water, you must be knowing that anionic surfactants and polymers are used to maintain the viscosity of produced water in the oil, in the oil well. And the oil and the produced water comes along with these polymers. And if that polymer goes into a nutshell, it can be a nightmare, and it is a nightmare. People don't know how to handle it because these form smooth and whatever happens. Whereas because of the hydrophobicity of DISORB, it does not give any problem. We can maintain the consistent results and flux. This is a typical PNID, which you all must be aware. It's a tank filter PNID. Also a nutshell filter PNID, and there's nothing different it just replaces the media with our DISORB media. Some applications, various applications you see. So I will just quickly show you the inlet water 2060, outlet is around 0.8, then we have 85 here, we have a 1700 feet inlet, and you're getting hydrocarbons and oils less than 1 milligram. So you see that it does not matter what the feed was, you are still getting very good quality water. Similarly, we take the worst cases. I'll show you one shocking case in the next slide. We have 140 to 156. We have 1.3 to 3.7. So you see, if you look at the outlet water, we are all within the 5 milligrams, which is norm, but we are much below the 5 milligram range. 250 comes down to less than 1. Here's the bilge water, which is 210, less than 0.36. Another bilge water with medium oil. Now here you will see the second last column, where was an extreme condition, 23,000 was the shock, and what came out was 110 milligrams. Now, can you feed up 23,000 to any filter for that matter and get a 110 out? So you can see the range it can capture. So DISORB services, retrofitting, supply of replacement, existing filters, media with DISORB. We address customer problems to be solved, carry out the necessary tests required. Pilot is always available if you want. Piloting can be done or media can be sent. What are the advantages? We will just run through them once again. So we have high oil engine capacity, low backwash volumes, 25 to 30% bed expansion, exceptional performance, 300 ppm and 100 ppm TSS, coming down to less than 3 ppm. Backwashing, obviously very, very good. Attrition rate less than 1% per year. No media preparation is required before startup. DISORB media performs well in high HQS application. When the sulfur loading is high, it really performs well. And it's neutral to polymers, bitumen, asphaltene, paraffins, and bacteria. Because these are all organics, and because of its hydrophobicity, oleophobicity, it repels all these. So that was about the DISORB and its advantages. And I'll quickly cover what other things we do. We have a lab, complete facility for carrying out DISORB oil water tests. We have a membrane-based, complete range of membranes starting from RO, nanofiltration to, and we mainly do the process application. Water is, wastewater is the key area, and especially toxic refractories, CODs, those are the areas which we concentrate on. Cavitation systems, so we have a complete lab facility, different type of equipment, quick list on clients, and I think I'm through with a quick roundup on what this DISORB media is all about. Now we can have a one-to-one chat or question-answer questions if you have.
Thank you, Lalit, for an interesting presentation on the DISORB media technology for the oil and gas applications. Excellent presentation. Let's, guys, you can ask any questions you have. Lalit has extensive experience about the water and wastewater system, so it's a good opportunity to learn from him. So feel free to post any questions you have.
When no question is asked, either you have understood everything, or you have understood nothing, or I am a very bad presenter. I think I am a very bad presenter, I feel like.
Now we do have questions. Stand by. Let me put the questions on. Yeah.
Is color removal possible with DISORB along with oil? Unfortunately, no, because it is not an absorbing media. Though the name can be deceptive, it is DISORB. So, and we are using coalescence as the main property of the media. It is an oleophobic material, that means it repels organics. So it definitely does not remove color. For color removal, you have to use different technology. Some of the oily wastewater are hot and warm, particularly in vegetable oil industry. How this DISORB media works for hot wastewater treatment? Very good question. DISORB media is quite stable under hot conditions. So normally water would not be going beyond 80 to 100 degrees centigrade max. So the media is very stable at those temperatures, and oil properties don't change, oleophobicity doesn't change, although it becomes less viscous at high temperatures. But it definitely does coalesce at that temperature also. So in vegetable oil industry, yes, it can work very well even at high temperatures. Coming to the next question, oily wastewater with fibers. Any suggestion on this? Now, I don't know which industry you're talking about. Fibers, if they are very, very small tailings kind of fibers, they tend to pass in a DISORB media. But if these are long fibers, we'll always have problems in a DISORB media because they entangle and they, make webs inside, and then they start, making the media into lumps. They sort of, go around the media in clusters, and that could be a challenge. So fibers, I would say, are avoidable. Does that answer your question? I don't know. You can tell me which industry this question is coming from. Adsorption versus coalescence principles. I think we discussed that in the few slides before. So adsorption is when you have a porous media and the liquid or the adsorbs into the media. That means it is picked up and it goes into the pores of the media, and that's called an adsorption. Very different from absorption, but adsorption is a surface phenomenon. Because of the charges, it captures the oil. So the principle of collecting oil in a nutshell filter is that it absorbs in its porosity. Whereas in coalescence, what happens is the oil does not enter the media at all. It starts losing its velocity and becoming droplet. Droplet becomes into a bigger droplet, and then it coalesces and then falls down. So these are two different approaches to treat oily waters. One is adsorption, which is also being used in the industry, and the second is coalescence, which is also very predominantly used, but we have different techniques. For coalescence, most of the equipment in oil industry work on coalescence. Dissolved air flotation works on coalescence. Corrugated plate interceptor works on coalescence. Induced gas flotation works on coalescence. So only thing is the nutshell filter, which is the last stage of produced water treatment in a typical produced water plant, uses adsorption, and we remove all these three and put one system which works on the principle of coalescence. I hope that clarifies.
Lalit, that's all the questions we have. Okay.
Yes.
So thank you very much. Before we end this session, I do request you to give your final remarks for the audience, please.
I really don't know who the audience is, but I hope and I believe that the presentation which I gave about the product was helpful and will be productive to you. And in case there are other applications, like I just heard something about vegetable oil, and suddenly someone asked about a fiber, maybe it's coming from a textile industry, or I don't know which industry, but there are different technologies to be used, and we have a very wide bouquet of technologies to offer. You will just type Diva Invertech on the web, you see our website, and I think my email ID, etc., will be shared by the forum. And more questions are more than welcome. And thank you very much for giving me this time. And I thank TechnoBiz for inviting me to address the audience which he has over the years. And thank you very much.
Thank you, Lalit, for being part of the Water and Wastewater Tech Talk by TechnoBiz. It is an interesting technology and an informative presentation. And as Lalit has mentioned, if you have more questions, feel free to reach out to him, or you can always write to us, so we'll communicate with you, or, so for further information. Thank you, Lalit, for being part of the session today.
Thank you very much.
Okay, guys, so that's the end of the session today on the DISORB system, enhancing produced water treatment efficiency and sustainability in the oil and gas sector by Mr. Lalit Vashishta, is a CEO, founder of the Diva Envitech Private Limited based in India. As you all understand, these guys are very specialized with huge experience, and they're a leading process engineering company, and in terms of the industrial wastewater filtration technologies and process engineering. So please make use of their expertise if you have issues or in projects involved related to these areas. Thank you all for joining this session today. Bye bye for now.
Thank you and take care.